Good evening, everyone. Happy Ugadi. Now, in the previous class, we have discussed this problem. The number of n cross n matrices that are simultaneously Hermitian, unitary, and diagonal is 2 power n. Okay. Now, next problem. Consider the matrix a 4 cross 4 matrix. Then A has no real eigenvalue. All eigenvalues of A are positive and real. All eigenvalues of A are negative. A has both positive and negative real eigenvalues. Observe this problem. Look at the matrix. The matrix is symmetric. Matrix is symmetric. That is one observation. Matrix is symmetric. One observation. Second observation. All the principal diagonal elements are 0. If all the principal diagonal elements are 0, trace of A equal to 0. Sum of eigenvalues is 0. That is the main point to solve this problem. Very simple. Observe. Matrix is symmetric. If the matrix is symmetric, compulsory eigenvalues are real numbers. If the matrix is symmetric, eigenvalues are real numbers. Sir, eigenvalues are real means positive real or negative real? By using trace A equal to 0, you can analyze very easily. Suppose if you have all positive, trace cannot be 0. If you have all negative, trace cannot be 0. Catch my point? Trace 0 means some positive, some negative. Some positive real numbers, some negative real numbers. By adding all these, you are going to get 0. That's why correct answer is A has both positive and negative real eigenvalues, because all the eigenvalues are not positive. Sir, how can you say that all the eigenvalues are not positive? Without finding eigenvalues, how can you say that? 1 minute, observe. If you check 2 cross 2 leading minor, what is 2 cross 2 leading minor? 0, 1, 1, 0. What is 2 cross 2 leading minor? 0 minus 1. Negative, na? A 2 cross 2 leading minor is negative, na? If all leading minors are positive, then all the eigenvalues are positive. Here one leading minor is negative, so all eigenvalues are not positive. So some positive, some negative. Therefore, A has both positive and negative real eigenvalues. That is the correct option. Understood? Piyush, mathematics is connected. Previous lecture connected to next lecture. Okay? Continuously you have to attend the class. Otherwise, some you may get, some you could not get. That is the problem. Observe. Next problem. Let M is, look at the matrix. M is 4 cross 4 matrix. Then M has only real eigenvalues, or M has imaginary eigenvalues, or all eigenvalues of M are 0, or none of them. Look at the entries of principal diagonal. All principal diagonal elements are real. Not only that, first row, second column, second row, first column, complex conjugates. 2i minus 2i, 7 minus I, 7 plus I minus I. So clearly matrix is Hermitian. Hermitian. If the matrix is Hermitian, all the eigenvalues of Hermitian matrix are always real. First option. Observe next problem. Look at the matrix. Matrix is Hermitian. Hermitian or not? Because principal diagonal elements are real. Remaining entries are satisfying Aij equal to Aji bar for all Ij. 6i minus 6i. Therefore, M is Hermitian. If the matrix is Hermitian, eigenvalues are real. Matrix is Hermitian, eigenvalues are real. Okay. Matrix is Hermitian, eigenvalues are real. Eigenvalues of M are real. R is correct. Next, M is Hermitian. Correct. I have to check whether IM is Q Hermitian or not. I have to check. That's why I am examining. Sir, how to check B is Hermitian or not? B power theta equal to minus B. If B power theta equal to B, it is Hermitian. B power theta equal to minus B, it is Q Hermitian. So we have to check here. IM is Q Hermitian. So IM whole power theta equal to I bar M bar transpose, because IM power theta is nothing but IM bar transpose. I is a complex number. It is not a matrix. That's why I bar. M is a matrix. That's why M bar transpose. M bar transpose is nothing but M power theta. So I bar is nothing but minus I. M bar transpose is nothing but M power theta. That is minus I into M power theta equal to M. Sir, how can we write M power theta equal to M? Since M is Hermitian. If M is Hermitian, M power theta equal to M. That's why M power theta I have written M. That is nothing but minus IM. IM whole power theta equal to minus. Observe here. Observe here. Am I audible? Now IM power theta equal to minus IM. Therefore, IM is skew Hermitian. IM is skew Hermitian. Therefore, M is Hermitian. IM is skew Hermitian. Eigenvalues of M are real are the correct statement. So Q and R only correct. Next problem. If a 3 cross 3 real skew symmetric matrix has an eigenvalue 2i, then one of the remaining eigenvalue is, observe, matrix is 3 cross 3 real skew symmetric. If matrix is 3 cross 3 real skew symmetric with one eigenvalue 2i, please remember, if one eigenvalue is 2i, compulsory other eigenvalue would be minus 2i. Therefore, other eigenvalue equal to minus 2i. I have given this property also. If a plus ib is eigenvalue of a minus ib is also an eigenvalue of a. Okay. So minus 2i. Is minus 2i is available in option? Not available. If not available, you have to think about other eigenvalue. Sir, two eigenvalues are known, but matrix is 3 cross 3, na? If matrix is 3 cross 3, it has 3 eigenvalues. Please remember, it is a real skew symmetry. If the matrix is real skew symmetry, we have one property. The determinant value of skew symmetric matrix of odd order is always 0. So determinant value of skew symmetric matrix of odd order is always 0. So determinant value 0. If determinant value is 0, product of eigenvalue is 0. If product of eigenvalue is 0, at least one of the eigenvalue is 0. Therefore, at least one of the eigenvalue is 0. That's why 0 is the correct option. Understood? Madhu? रियल स्क्यू सिमेट्रिक मैट्रिक्स के लिए कॉम्प्लेक्स आइगन वैल्यूज मिलेगा. व्हाट इज द प्रॉपर्टी? आइगन वैल्यूज ऑफ स्क्यू सिमेट्रिक मैट्रिक्स आर either 0 or purely imaginary. Either 0 or purely imaginary. Purely imaginary means complex eigenvalues are not. पहले प्रॉपर्टीज पढ़ो. Very good. Observe here. Matrix is triangular. If matrix is triangular, eigenvalues of triangular matrix are nothing but its leading diagonal elements. So here, eigenvalues of A are one minus 1 by 2 plus I root 3 by 2 minus 1 by 2 minus I root 3 by 2. Observe, your problem is not trace of A. Your problem is trace of A power 1 or 2. You have to calculate trace of a power 102. So to calculate trace of a power 102, shall we multiply matrix A 102 times? That is a foolish thing. Okay. With the help of eigenvalues, we have to calculate trace. So we have to calculate eigenvalues of a power 102. Eigenvalues of a and a power 102 are not same, Laksh. Eigenvalues of a and a power 102 are not same. You have eigenvectors are same, values are not same. Remember the properties. Eigenvectors of a and a power 102 are same. Eigenvectors are same, not values. If lambda is eigenvalue of a, lambda power 102 is eigenvalue of a power 102. If lambda is eigenvalue of a, lambda power 102 is eigenvalue of a power 102 because you have property. If lambda is eigenvalue of a, lambda power m is eigenvalue of a power m. That's why we have to calculate 1 power 102 minus 1 by 2 plus I root 3 by 2 whole power 102. 1 power 102 is 1. Okay. But minus 1 by 2 plus I root 3 by 2 whole power 102. That is in the form of a plus ib. A plus ib whole power 102. Expansion consisting 103 terms. Don't go for expansion. Apply simple logic. Look at the entries properly. This is nothing but 1. This is nothing but omega. This is nothing but omega square. Okay, sir, what are 1 omega square? Omega means e power I 2 pi by 3. That is called omega. Cube root of unity. Cube root of unity. E power I 2 pi by 3 is nothing but cos 2 pi by 3 plus I sin 2 pi by 3. Okay. Cos 2 pi by 3 is minus 1 by 2. Sin 2 pi by 3 is root 3 by 2. Because 2 pi by 2 means 2 pi by 3 means 120 degrees. 120 degrees. Second quadrant cos negative, sin positive. That's why minus 1 by 2 plus I root 3 by 2. Next, omega square. E power I 2 pi by 3 whole square. मतलब क्या? E power I 4 pi by 3. Now, e power I 4 pi by 3 is cos 4 pi by 3 plus I sin 4 pi by 3. Okay, not 4 pi by 9. 4 pi by 3 only. Now, cos 4 pi by 3 is 240 degrees means third quadrant, cos negative, sin negative. Minus 1 by 2 minus I root 3 by 2. Okay. Now, sir, what about omega cube? If you take omega cube, e power I 2 pi by 3 whole cube, that is e power I 2 pi cos 2 pi plus I sin 2 pi. That's why 1 plus I into 0, 1. Omega cube is 1. Understood? So, eigenvalues of A are nothing but 1 omega square. Okay? Now, I have explained you clearly what is omega square, what is omega cube. Now, come to the problem. Our problem. What is our problem? We have to calculate trace of A power 102. to calculate trace of a power 1 or 2, we are going to calculate eigenvalues of a power 1 or 2. Now, eigenvalues of a power 1 or 2 are 1 power 1 or 2, omega power 1 or 2, omega square whole power 1 or 2. This can be written as 1 power 1 or 2 is 1. Omega power 1 or 2 can be written as omega cube whole power 34. 34 3 ja 1 or 2. Next, omega square whole cube whole power 34. Next, 1 omega cube whole power 34. Next, omega square whole cube, omega cube whole square, both are same. Omega square whole cube, omega cube whole square, both are equal. A power m whole power n, a power n whole power m. Now 1 omega cube is 1, 1 power 34 is 1, 1 power 34 is 1. So eigenvalues of a power 1 or 2 are 1 1 1. Therefore trace of a power 1 or 2 is 1 plus 1 plus 1, 3. So trace of a power 1 or 2 is 3. Understood? Omega square whole cube, omega cube whole square, both are equal. Omega cube is 1, so 1 square is 1. 1 square whole power 34 is 1. Understood? माइनस आई फॉर्म क्या होगा सारा? माइनस आई किधर मिलेगा? वेयर इज माइनस आई? वेयर इज माइनस आई? अब जाओ नेक्स्ट प्रॉब्लम. Let alpha is equal to, correction is here, alpha equal to e power I 2 pi by 5. Okay, now alpha is e power I 2 pi by 5 and matrix M is 1 alpha, alpha square and so on. Okay, it is a 5 cross 5 matrix. Then trace of I plus m square. Trace of I plus m square. Trace of I plus m square. Concentrate here. Excellent problem. Matrix is triangular matrix. matrix is triangular. If the matrix is triangular, eigenvalues of a triangular matrix are its leading diagonal elements. That's why we can write eigenvalues of M are its leading diagonal elements. 1 alpha, alpha square, alpha cube, alpha power 4. Concentrate here. I am explaining here. Eigenvalues of M are 1 plus alpha square plus alpha cube plus alpha power 4. Okay. Now, we know eigenvalues of M. We can calculate eigenvalues of M square. Sir, why you are calculating eigenvalues of M square? What is the purpose? Our job is to calculate trace of I plus M square. Okay. Now, trace of I plus M square is nothing but trace of I plus trace of M plus trace of M square. We have one property. Sum of eigenvalues equal to trace of the matrix. Sum of eigenvalues equal to trace of the matrix. That's why we are going to calculate eigenvalues. With the help of eigenvalues, we are going to calculate sum of eigenvalues. Then we will get the trace. We are going to substitute trace here. Understood? A matrix is 5 cross 5. Therefore, trace of identity matrix of order 5 is 5. That is very clear. I have to calculate trace of M and trace of M square. Okay? Now come here. You know eigenvalues of M. With the help of eigenvalues of M, we can calculate eigenvalues of M square. We have a property. Eigenvalues of M square are 1 square, alpha square का whole square, alpha cube whole square, alpha power 4 whole square. Okay, now 1 square is 1, alpha square whole square is alpha power 4, alpha cube whole square is alpha power 6, alpha power 4 whole square is alpha power 8. Okay, now observe 1 alpha square, alpha power 4, alpha power 6 and alpha power 8 can be written as alpha and alpha cube. Sir, how can you write alpha power 6 in the form of alpha? How can you write alpha power 8 in the form of alpha cube? There is one hint in the problem. What is that? Alpha equal to e power I 2 pi by 5. Alpha equal to e power I 2 pi by 5. Since alpha equal to e power I 2 pi by 5, alpha power 5 is e power I 2 pi by 5 whole power 5. Raise power 5 on both sides. This 5 and this 5 are cancelled. Now, alpha power 5 equal to e power I 2 pi. E power I 2 pi is nothing but cos 2 pi plus I sin 2 pi. Okay. Now, alpha power 5 equal to 1 because cos 2 pi is 1, sin 2 pi is 0. That is 1. That's why alpha power 5 is 1. Since alpha power 5 is 1, alpha power 6 is alpha. That's why I have written alpha power 6 in the form of alpha. Catch my point? Suppose if you multiply this alpha power 5 equal to 1 on both sides with alpha cube, alpha power 5 into alpha cube equal to alpha cube, alpha power 8 equal to alpha cube. Catch my point? That's why I have written alpha power 8 is alpha cube. So now the conclusion is 1 minute observe, not completed. The conclusion is eigenvalues of m 1 alpha alpha square. Here also you have 1 alpha alpha square, alpha cube, alpha power 4, alpha power 4. In this problem, eigenvalues of m and eigenvalues of m square both are equal. Okay, now trace of m and trace of m square are equal in this problem. Okay, now that's why I am writing. Observe here, trace of m equal to 1 plus alpha square plus alpha cube plus alpha power 4. Here trace of m square, that is also 1 plus alpha square plus alpha cube plus alpha power 4. Now our job is to find out what is the value of 1 plus alpha square plus alpha cube plus alpha power 4. I am going to find out. Observe. Since alpha equal to e power I 2 pi by 5, we found that alpha power 5 is 1. Okay? Now, come here. Since alpha power 5 is 1, therefore, 1 minus alpha power 5 is 1 minus alpha power 5 is 0. Sir, what is alpha here? Alpha value is e power I 2 pi by 5. Sir, what is e power I 2 pi by 5? Cos 2 pi by 5 plus I sin 2 pi by 5. That is the meaning. If you want to write, you can write cos 72 degrees plus I sin 72 degrees. Okay? Come here. 1 minus alpha power 5 is 0. 1 minus alpha power 5 can be written as 1 minus alpha into 1 plus alpha square plus alpha cube plus alpha power 4. Any doubt? 1 minus alpha power 5 is nothing but 1 minus alpha into 1 plus alpha square plus alpha cube plus alpha power 4. Avadesh, I have to explain a square minus b square formula. 1 minus t square equal to 1 minus t into 1 plus t. 1 minus t cube equal to 1 minus t into 1 plus t square. If you have cube, you got till 2. If you have power 5, till 4. Got it? Now, alpha value is not 1. Cos 72 degrees plus I sin 72 degrees is not 1. Never be 1. That's why conclusion is alpha is not 1. If alpha is not 1, 1 minus alpha is non-zero. If 1 minus alpha is non-zero, compulsory 1 plus alpha square plus alpha cube plus alpha power 4 equal to 0. Sir, how can we say that? Algebra, x into y equal to 0. In algebra, x into y equal to 0. Either x is 0 or y is 0. Here x is non-zero, then compulsory y is 0. Because 1 minus alpha power 5 is nothing but 1 minus alpha into 1 plus alpha plus till alpha power 4. This is non-zero. If this is non-zero, then other term compulsory 0. Otherwise, product cannot be 0. Na? That's my point. Finally, the conclusion is 1 plus alpha square plus alpha cube plus alpha power 4 is 0. If this value is 0, trace of m is nothing but 1 plus, that is 0. Na? If trace of m is 0, trace of m square is also 0, because 1 plus alpha square plus alpha cube plus alpha power 4. So trace of m is 0, trace of m square is 0. So this value 0, this value 0. 5 plus 0 is 5. Therefore, trace of I plus m square is 5. Answer is 5. Got it? Next problem. In the previous problem, you have to note down clearly in a sequential order. Okay. Surbhi, alpha power 5 equal to 1 hai to, if you multiply with alpha on both sides, alpha power 5 into alpha equal to 1 into alpha power 6 equal to alpha. Any doubt? Right. Observe this problem. The eigenvalues of a 2 cross 2 matrix X are -2 and -3. Then eigenvalues of matrix X plus I inverse multiplied with X plus 5y. It is completely designed on properties of eigenvalues. Eigenvalues of X are -2, -3. If eigenvalues of X are -2, -3, what about eigenvalues of X plus 5y? Tell me now. -2 plus 5, -3 plus 5 or not? -2 plus 5 is 3. -3 plus 5 is 2. 3 and 2. Now, if eigenvalues of X are -2 and -3, what about eigenvalues of X plus I? X plus I -2 plus 1, -3 plus 1. -2 plus 1 is -1. -3 plus 1 is -2. Next. Eigenvalues of X plus I whole inverse are 1 by -1, 1 by -2. Now eigenvalues of X plus I whole inverse multiplied with X plus 5I. You have to multiply corresponding eigenvalues. 1 by -1 multiplied with 3. So 1 by -1 multiplied with 3, 1 by -2 multiplied with 2. The result is -3 comma -1. So final answer is -3 comma -1. -3 comma -1. Understood? Next. Next. The condition for which eigenvalues of matrix A are positive. The condition for which eigenvalues of matrix A are positive. Observe. Is there any condition for which eigenvalues of matrix are positive? We have only one. Very good, Saif. All the leading minors of any symmetric matrix are positive, then compulsory its eigenvalues are positive. So here matrix is symmetric. Matrix is symmetric. If you examine leading minors, you have two leading minors. 1 cross 1 leading minor is 2. 1 cross 1 leading minor is 2, positive. Now, suppose 2 cross 2 leading minor is also positive, then compulsory eigenvalues would be positive. Therefore, for which condition the matrix has positive real eigenvalues? If this 2 cross 2 leading minor is positive, then compulsory you will have all the eigenvalues of your symmetric matrix would be positive. Okay, so 2k minus 1 greater than 0, 2k greater than 1, k greater than 1 by 2. So correct option is k greater than 1 by 2, first option. Let A, B, C are positive real numbers such that B square plus C square less than A less than 1. Consider the 3 cross 3 matrix. All eigenvalues are negative real numbers. All eigenvalues are positive real numbers. A can have positive as well as negative real eigenvalues. Eigenvalues of A can be complex number. 1 minute. Last option is straight away you can eliminate. Okay? Because matrix is symmetric. If matrix is symmetric, eigenvalues of symmetric matrix are always real. That's why last option is straight away eliminated. Now, in the first three options, which one? He has provided one relation. Based on that relation, you have to analyze. Observe. 1BC BA0 C01. Come here. B square plus C square less than A less than 1. 1 minute, observe. Sir, B square plus C square is greater than 0 or less than 0? Sum of squares of B and C. B is negative or positive, doesn't matter. B square is positive na, C square is positive na, B square plus C square is positive na. So this is greater than 0 or not? And that is my point. Now, matrix is symmetric. Matrix is clearly symmetric. It is a symmetric matrix. When matrix is symmetric, whether you have positive real eigenvalues or negative real eigenvalues, you can justify by using one property. leading minors property. So first examine leading minors. Observe. 1 cross 1 leading minor is 1. That is positive. Clear. Clear. Examine 2 cross 2 leading minor. 2 cross 2 leading minor is 1BBA. A minus B square. Clearly A minus B square is greater than 0. Sir, how can you say that? Come here by using this relation. B square plus C square less than A. So A greater than B square plus C square. A greater than B square plus C square. So A minus B square is greater than C square or not? C square is greater than 0 or not? C square is greater than 0 or not? Therefore, that is positive. Clear now? Next, examine 3 cross 3 leading minor. 3 cross 3 leading minor. 1 BC. Now multiply 1 of A minus 0 minus B of B minus 0 plus C of 0 minus AC. Next, A minus B square minus AC square. A minus B square minus AC square. Observe. A of 1 minus C square minus B square. I have taken A common here. 1 minus C square minus B square from the given relation. Observe. 1 greater than A greater than B square plus C square greater than 0. Now come here. Observe. 1 greater than B square plus C square. So 1 minus C square is greater than B square. 1 minus C square is greater than B square. Now A multiplied with 1 minus C square is greater than B square or not? A multiplied with 1 minus C square is greater than B square or not? Greater than B square. If this is greater than B square, from that greater than B square, if you subtract B square, are you getting positive value or not? Which one is A into 1 minus C square? A into 1 minus C square is greater than B square. If A into 1 minus C square is greater than B square, A into 1 minus C square minus B square is greater than 0. That's why I am going to write this value greater than 0. So 1 cross 1 leading minor is greater than 0. 2 cross 2 leading minor is greater than 0. 3 cross 3 leading minor is also greater than 0. Because A is a positive value which is greater than B square plus C square. So if you multiply 1 minus C square with a positive value, result is positive or not? Okay. So here 1 minus C square is greater than B square. Suppose 3 greater than 2. If you multiply 3 with some positive value, so that product is greater than B square or not? Automatically greater than. That's why this result is greater than 0. So all 3 cross 3 leading minors are positive. Matrix is symmetry. Therefore, eigenvalues of A are positive and real. Second option is correct. This problem and this problem both are designed on the same logic. Here they have given numericals. That's why you have solved very easily. But here A, B, C are given. A, B, C are positive real numbers. Okay, that's why to analyze this concept it consumes time, but both the problems are designed on the same property. Understood? Next, observe this problem. Let A be a 4 cross 4 matrix with the real entries such that minus is printed here, minus is printed here, 1 is printed here. So it is nothing but minus 1. Please remember. Minus 1, 1, 2 minus 2 are eigenvalues of A if B is A power 4 minus 5A square plus 5Y, then which of the following is incorrect? Keep in mind, incorrect, false. Eigenvalues of 4 cross 4 matrix are minus 1, 1, minus 2, 2. Okay, next. We have to calculate eigenvalues of A power 4 minus 5A square plus 5Y. Observe. Eigenvalues of A power 4 are 1 minus 1 power 4, 1 power 4, minus 2 power 4, 2 power 4. Any problem? Next. Eigenvalues of 5y are 5 comma 5 comma 5 comma 5. Subodh Gupta, I have written in this order. Same order I am calculating. What is wrong in that? Huh? Whether minus 2, 2 or 2 minus 2, what is the problem in that? Now, A power 4 plus 5i. Eigenvalues of A power 4 plus 5i. Rajukumar, burra vadra naina. minus 5, 5 plus 5 कैसा आएगा जी? आइडेंटिटी मैट्रिक्स का आइगन वैल्यूज क्या है? 1 1 1 1 ना, 1 plus 5 6, 1 plus 5 6, 16 plus 5 21, 16 plus 5 21. These are the eigen values of A power 4 plus 5y. Now I have to subtract eigen values of minus 5a square. So what are eigen values of A square? 1 1 4 4. So 5a square are 5 5 20 20. So eigen values of 5a square are 5 5 20 20. Now subtract. Eigenvalues of A power 4 plus 5y minus 5a square are 6 minus 5 1, 6 minus 5 1, 21 minus 21, 20 minus 21 minus 21. So eigenvalues of B are 1 1 1 1. So conclusion is eigenvalues of A are eigenvalues of matrix A are minus 1 1 minus 2 2. Eigenvalues of B are 1 1 1 1. Okay, now we have to calculate determinant value of A plus B and trace of A plus B. So first calculate eigenvalues of A plus B. What is determinant value of B? Determinant value of B is 1. So that is correct. Which option? This is true. Next, you have to calculate eigenvalues of A plus B. You have to add corresponding entries. -1 plus 1, 1 plus 1, -2 plus 1, 2 plus 1. That is nothing but 0, 2, -1, 3. Okay. Now, trace of A plus B is 0 plus 2 minus 1 plus 3, 5 minus 1, 4. Okay. Determinant value of A plus B, 0 multiplied with 2 multiplied with -1 multiplied with 3, 0. Determinant value of A plus B is 0. Trace of A plus B is 4. Trace of A plus B. Trace of A plus B. 4 na? Correct. That is also true. First A, B, C are true. Therefore, last option is incorrect. It is false. No problem. You can cross check. What about eigenvalues of A minus B? -1 minus 1. 1 minus 1. -2 minus 1. 2 minus 1. -2, 0, -3, 1. Trace of A minus B is -2 plus 0, -3 plus 1, -4, -4. Okay. Next problem. Let A be a 3 cross 3 matrix such that determinant value of A minus I equal to 0. A is a 3 cross 3 matrix such that determinant of A minus I equal to 0. If trace of A is 13, det A is 32, then sum of the squares of eigenvalues. If trace of A is 13, trace of A is 13, det A is 32. First you have to calculate eigenvalues. Observe, he has provided one hint directly. Generally, to calculate eigenvalues of any matrix, you are going to write characteristic equation. Determinant of A minus lambda equal to 0. So, you compare this equation with determinant of A minus lambda equal to 0. You will get one eigenvalue. By comparison. One eigenvalue 1. Now, matrix is 3 cross 3. It has 3 eigenvalues. So, lambda 1 plus lambda 2 plus third eigenvalue 1 equal to 13. Because trace is nothing but sum of eigenvalues. Sir, what about determinant? Determinant equal to product of eigenvalues. So, lambda 1 multiplied with lambda 2 multiplied with 1 equal to 32. Therefore, sum of eigenvalues equal to trace, product of eigenvalues equal to determinant. Since one eigenvalue is 1, I have substituted one eigenvalue 1, one eigenvalue 1. Other two eigenvalues are unknown. Now lambda 1 plus lambda 2 equal to 12. Lambda 1 multiplied with lambda 2 equal to 32. This is called equation 1. This is called equation 2. From 1 and 2, you can write lambda 1 is 4, lambda 2 is 8. Or lambda 1 is 8, lambda 2 is 4. Therefore, eigenvalues of A are 1, 4, 8. Eigenvalues of A are 1, 4, 8. Therefore, lambda 1 square plus lambda 2 square plus lambda 3 square is 1 plus 16 plus 64. That is 81. Understood? Now, which of the following is true? Which of the following is true? Whether the matrix is diagonalizable or not. Second statement is first matrix is diagonalizable. Second statement is second matrix is diagonalizable. Whether both the statements are true or both the statements are false, we have to identify. Diagonalizable, I have not explained. But when a matrix is diagonalizable, I have explained. I have explained when a matrix is diagonalizable. I have not explained process of diagonalization. This problem is not depending on the process. The problem is designed on you need not to diagonalize. You need not to diagonalize. You have to check whether this matrix is diagonalizable or not. That concept I have explained. I already told you, for each eigenvalue of your matrix, algebraic multiplicity and geometric multiplicity coincides, then the matrix is diagonalizable. Okay? Do I explain the concept or not? When a matrix is diagonalizable, if AM and GM of each eigenvalue coincides, then that matrix is diagonalizable. So your job is to check whether this matrix is diagonalizable or not. They never questioned you diagonalize this matrix. They never questioned. They have questioned whether this matrix is diagonalizable or not. You have to test. Okay? Please remember. If you would like to test whether matrix is diagonalizable or not, first your job is to calculate eigenvalues. First, your job is to calculate eigenvalues. Next, you have to analyze independent eigenvectors. We are interested about linearly independent eigenvectors. That is called geometric multiplicity. After that, we will come to whether the matrix is diagonalizable or not. Okay? Now, come to the problem. Excellent problem. Observe. Matrix is 4 cross 4. Concentrate here. Two two 0 0 2 1 0 0. Zero zero 3 0 0 0 1 4. Yes, Vivek. Very good. Yesterday I have explained you one technique, partition technique. Here x1, x2, x3, x4. Here x1 and x2 are present, x3, x4 are absent. X1, x2 are present, x3, x4 are absent. Here x1, x2 are absent, x1, x2 are absent. So 4 equations we have. In that 4, two equations one side, two equations another side. Observe. From this, you can write 2x1 plus 2x2 equal to 0. 2x1 plus x2 equal to 0. From this, 3x3 plus 0x4, x3 plus 4x4 equal to 0. Catch my point? Whether diagonalizable or not, by this you won't get. Oh Prajwal, you watch the recorded video, man, first. If you already calculated, you should not put question mark. You have to give the statement. Now observe here. First two equations are in terms of x1, x2. Next two equations are in terms of x3, x4. It is clearly partitioned. So with the help of these two equations, you can get two eigenvalues. With the help of these two equations, you can get two eigenvalues. Observe. 2, 2, 2, 1. That is your matrix. Now, determinant of A minus lambda equal to 0 gives eigenvalues. 2 minus lambda 2, 1 minus lambda equal to 0. 2 minus lambda into 1 minus lambda minus 4 equal to 0. That is 2 minus 2 lambda minus lambda plus lambda square minus 4 equal to 0. From this, lambda square minus 3 lambda minus 2 equal to 0. So lambda equal to 3 plus or minus square root of b square 9 minus 4ac plus 8 by 2a 2. 3 plus or minus root 17 by 2. 3 plus or minus root 17 by 2. You got two eigenvalues. Other two eigenvalues you have to calculate from here. 3, 0, 1, 4. You can get very easily. Why? Because it is a triangular matrix, na? Therefore, the eigenvalues of triangular matrix are nothing but leading diagonal elements, 3 and 4. So in this problem, your matrix is 4 cross 4 with eigenvalues 3 plus root 17 by 2, 3 minus root 17 by 2, 3 comma 4. 4 distinct eigenvalues. If you have distinct eigenvalues, for every distinct eigenvalue, there will be one distinct independent eigenvector. Corresponding to first eigenvalue, there is one independent eigenvector. Next eigenvalue, one independent eigenvector, another independent eigenvector, another independent eigenvector. So, 4 independent eigenvectors corresponding to a 4 cross 4 matrix. You have 4 independent eigenvectors. So, what is AM of this eigenvalue? 1. What is GM? 1. So, AM and GM of each eigenvalue coincides or not? AM and GM of each eigenvalue AM and GM of each eigenvalue are same. Therefore, matrix A is diagonalizable because 4 distinct eigenvalues. Therefore, for every distinct eigenvalue, there is one independent eigenvector. 4 distinct eigenvalues, 4 distinct independent eigenvectors. Therefore, the matrix is diagonalizable. First statement is true. Now come to second one. You have a 2 cross 2 matrix is given, that is 2102. 2102. It is a triangular matrix. Therefore, eigenvalues are nothing but leading diagonal elements. Next, we have to find out corresponding to eigenvalue 2. We have to find out eigenvector. What is algebraic multiplicity of eigenvalue 2? What is algebraic multiplicity of eigenvalue 2? 2. Because 2 times eigenvalue is repeated. That's why AM is 2. Sir, what about GM? I am going to find out. Consider A minus 2i of x equal to 0. 2 minus 2, 1. 0, 2 minus 2 of x1, x2 equal to 0, 0. Continuation. 0, 1, 0, 0 multiplied with x1, x2 equal to 0, 0. What is rank? Rank is 1. Number of variables 2. Free variables 2 minus 1, 1. Okay. Now the equation is x2 equal to 0. The equation is x2 equal to 0. Let us take x1 equal to k. Therefore, eigenvector is k0. K into 1, 0. Therefore, the number of linearly independent eigenvector 1 and only 1. Here, geometric multiplicity of eigenvalue 2 is 1. AM of eigenvalue 2 is 2. GM of eigenvalue 2 is 1. That's why the matrix is therefore AM not equal to GM. Therefore, it is not diagonalizable. Understood? So, second statement is false. This is true. So, which one is true? Only one. Only first statement is true. Second statement is false. Sir, if AM and GM are not coincides, why the matrix is not diagonalizable? If you understand the process of diagonalization, you will get it. I am explaining that process also. Concentrate. First, you have to calculate eigenvalues. Suppose your matrix is 3 cross 3. Calculate eigenvalues. That is step 1. Suppose you have 3 eigenvalues. Lambda 1, lambda 2, lambda 3. Suppose. Next, step 2. Calculate eigenvectors x1, x2, x3. Step 3. Write model matrix P. Sir, what is model matrix P? Collection of all eigenvectors x1, x2, x3. You have to write x1, x2, x3. Okay. you will get model matrix. Step 4, calculate P inverse. Calculate P inverse. Step 5, calculate P inverse AP. A means given matrix, P means your model matrix, P inverse means you have calculated inverse of model matrix, that one. Okay, calculate P inverse AP. 100% P inverse AP is equal to diagonal matrix D. Sir, what is this diagonal matrix? You will get one diagonal matrix with eigenvalues of A, lambda 1, lambda 2, lambda 3 in the principal diagonal. Remaining entries are 0. Okay, eigenvalues of A and eigenvalues of this diagonal matrix D are same. This process is known as diagonalization. So when a matrix is diagonalizable means if algebraic multiplicity and geometric multiplicity of each eigenvalue coincides, then only the matrix is diagonalizable. Sir, if they are not coincides, then the matrix is not possible to diagonalize. What is the reason? I am explaining. In this problem 2102, you have two eigenvalues. Lambda 1 is 2, lambda 2 is 2. But you got only one independent eigenvector. X2 is not available. You have only one independent. Sir, what about X2? X2 is not available. Not available means you have to take dependent. If you take dependent, what happened? If you take dependent, sir, how to take dependent? If you take dependent, how to take dependent? In the place of K, you put 2, you will get 2 0. If you put 3, you will get 3 0. If you put 4, 4 0. Like that, you can generate. If you take dependent, what happened? Model matrix P is X1 is available. X2, you are going to take dependent. If you take dependent, what happened? If you take dependent, what happened? In the matrix, if at least one vector is dependent, the set is dependent. If the set is dependent, determinant value of P becomes 0. If determinant value of P becomes 0, P inverse does not exist. P inverse does not exist. If P inverse does not exist, can you write P inverse AP? Possible? Not possible. Not possible. Understand? That's why it is not possible to diagonalize a matrix if algebraic multiplicity and geometric multiplicity of each eigenvalue does not coincide. Catch my point? Because of this logic, it is not possible to diagonalize if AM and GM of each eigenvalue does not coincide. Okay, right. Come to the next problem. For the matrix M, consider the following statements. Characteristic equation of M is lambda cube minus lambda equal to 0. M inverse does not exist. The matrix M is diagonalizable. First, your job is to calculate eigenvalues. If you calculate eigenvalues, you will get the clarity. Okay? Right. Determinant of M minus lambda equal to 0. determinant of m minus lambda equal to 0. 1 minus lambda, 0 minus 1, 0, 1 minus lambda, minus 1, 1, 1, minus 2 minus lambda equal to 0. Okay. Now, if sum of eigenvalues of each and every row is same, you will get only one eigenvalue na. To analyze that remaining two statements, I would like to expand. Okay. Now, 1 minus lambda of minus 2 minus lambda plus 2 lambda plus lambda square plus 1 minus 1 of 0 minus 1 minus lambda equal to 0. From this, 1 minus lambda into lambda square plus lambda minus 1. Okay. Now, minus into minus plus, 1 minus lambda equal to 0. Do one thing, take 1 minus lambda common. Lambda square plus lambda minus 1 plus 1 equal to 0. From this, 1 minus lambda into lambda square plus lambda equal to 0. That implies 1 minus lambda into lambda plus 1 equal to 0. Eigenvalues are nothing but lambda equal to 1, 0, minus 1. Three distinct eigenvalues. If you have three distinct eigenvalues, compulsory three distinct linearly independent eigenvectors. If you have three distinct eigenvalues, 100% you have three distinct linearly independent eigenvectors. Therefore, matrix is diagonalizable. M is diagonalizable. One statement is clear. Next, come here. Lambda square plus lambda minus lambda cube minus lambda square equal to 0. Lambda square minus lambda square cancel. Lambda cube minus lambda equal to 0. The characteristic equation is lambda cube minus lambda. That statement is also clear. This is true. Diagonalizable is true. M inverse does not exist. Yes, that is also true. Because one of the eigenvalue is 0. Na? If one of the eigenvalue is 0, if one eigenvalue is 0, determinant value of M equal to product of eigenvalues, na? That is 0. Na? So M inverse does not exist. M inverse does not exist is true. Matrix is diagonalizable is true. And lambda cube minus lambda equal to 0 is the characteristic equation is also true. Understood? All three statements are correct. P is correct, Q is correct, and R is correct. Therefore, first option is correct. Understood? Understood? Next. First read the statement. %90 of the students get confused. First read the statement. First understand the statement. After that, just I am going to Question you will get the answer automatically. Neha, inverse does not exist. Counts का किसका inverse does not exist? Matrix M का, not model matrix का. Neha, M is determinant value of original matrix is 0. It doesn't mean that model matrix is 0. No, model matrix is formed by eigenvectors. That is not 0. The determinant value of model matrix is not 0. Determinant value of original matrix is 0. Clearly, I have given the proof now. 3 distinct eigenvalues. Therefore, 3 distinct independent eigenvector. If you have 3 distinct independent eigenvector, matrix is diagonalizable. Okay. Next. Got any conclusion? Please observe. Matrix A is n cross n, real valued square symmetric matrix of rank 2. Sigma I equal to 1 to n, sigma j equal to 1 to n, aij square equal to 50. Oh, Kundu, Rishiraj, don't apply innovative ideas. First, you have to process the data with the help of Pranshu Kumar Yadav. You are in confusion. Clearly, I have explained 3 times, 4 times. If your matrix M is singular, you can't say that your matrix is not diagonalizable. There is no link between whether your matrix is singular or non-singular with diagonalization. The link between diagonalization is eigenvectors of your matrix must be linearly independent. Sir, when our eigenvectors are linearly independent, whenever algebraic multiplicity and geometric multiplicity of each eigenvalue coincides, then 100% your matrix is diagonalizable because Avadesh, not only distinct Baba, not only distinct. If distinct 100%, in similar also possibility is there. If eigenvalues are repeated, then also there is a possibility. I have given one example. 2, 2, 2. Video problem. You have to check free variable. Yes, exactly. If you have repeated eigenvalues, you have to check free variables. Okay. Free variables gives you idea about independent eigenvectors. Okay. Right. Concentrate here. So video problem. Shall I continue? Okay. Observe here. I have explained you one property. In if your matrix is n cross n, concentrate, if your matrix is n cross n, if you have n rows are identical, n minus 1 eigenvalues would be 0. Suppose in a matrix, if you have n rows are identical, n minus 1 eigenvalues would be 0. Do you remember that property? Okay. Come to the point. In a matrix, if you have n rows are identical, n minus 1 eigenvalues are 0. Clear? Sir, if n rows are identical, what is rank of your matrix? N rows are identical, matrix is n cross n. N rows are identical. N rows identical means all the rows are identical, na? So what is rank? 1. Concentrate here, please. Rank of A is 1. Matrix is n cross n. N minus 1 eigenvalues are 0. Sir, suppose matrix rank of the matrix is 2. Matrix is n cross n. Then how many eigenvalues would be 0? That is my question. 2. Rank 2. Rank is 1. N minus 1 eigenvalues are 0. If rank is 2, how many eigenvalues would be 0? N minus 2 eigenvalues would be 0. Catch my point? Now come to the problem. Come to our problem. Our problem is similar to that property only. Matrix is n cross n symmetric. A symmetric purpose is different. N cross n matrix only I am taking. Symmetric purpose next I am going to implement. Observe. N cross n matrix with rank 2. Therefore, n minus 2 eigenvalues are 0. Okay. So, lambda 1, lambda 2 are non-zero. Remaining n minus 2 eigenvalues are 0. These are all n minus 2 eigenvalues. These are all 2 eigenvalues. Total n minus 2 plus 2 n eigenvalues. Come to the point. He has given one condition. What is the condition? Sigma sum of I equal to 1 to n, sum of j equal to 1 to n, aij square. That represents sum of the squares of eigenvalues. Sum of squares of eigenvalues. Sum of squares of eigenvalues is equal to 50. So, lambda 1 square plus lambda 2 square plus 0 square plus 0 square. How many times you add? The result is 50. With the help of these two hints, you are going to analyze two statements. What is first statement? It is concept based question. Please concentrate. One of the eigenvalue must be between minus 5 to 5. Sir, why one of the eigenvalue must be in between minus 5 to 5? You are going to find out squares of sum of the squares. If you take here lambda 1, suppose beyond the interval other than minus 5 to 5, suppose if you take one value beyond this interval, suppose 7 square 49. So other one compulsory 1 to get 50. So this one is lies in the interval or not? So to satisfy to satisfy this equation, compulsory one of the eigenvalue must be in the interval -5, 5. So that statement is true. First statement is correct, true. Next statement, concentrate. The eigenvalue with largest magnitude means length, must be the eigenvalue with largest magnitude must be greater than 5. Can you accept? Suppose if I take greater than 5 means if I take 8, 8 square 64 plus lambda 2 square equal to 50. So lambda 2 square equal to 50 minus 64 minus 14. Lambda, shall I take imaginary value? When you are going to use the condition symmetric here. Why they have provided symmetric? Because you have to understand that the eigenvalues must be real. If you take square of a, you have taken one contradictory, okay, you have taken one eigenvalue with largest magnitude, so it is a contradiction. Here you have taken 8, because of that 8 you got contradiction. That's than 5. They have given. Understood the logic? Eigenvalue, it means for every largest not suitable. For 9 it is 9, 10, 11 like that. That's why the statement is false. Madhu, if you would like sigma lambda square statement, 1 square. Now come here. Consider the matrix P. Vectors are, what is order of the matrix P? 2 cross 1. मैट्रिक्स P स्क्वायर मैट्रिक्स होना चाहिए ना. Matrix must be 2 cross 2. 2 cross 2. Okay, concentrate. P is 2 cross 2, whose only eigenvectors are multiples of 1, 4. Your eigenvector is 1, 4. They have given only one eigenvector. The other eigenvector is not provided. What they have mentioned, whose only eigenvectors are multiples of 1, 4. When an eigenvector is multiple of another eigenvector, am I audible? Okay, concentrate. Matrix is 2 cross 2. Matrix is 2 cross 2. One eigenvector is 1, 4. Other eigenvector is multiple of 1, 4. Multiple of 1, 4. It is not my assumption. They have given. Sir, one eigenvector is multiple of another eigenvector means immediately you have to understand that there is only one independent eigenvector. There is only one independent eigenvector. One independent eigenvector. Concentrate. By this, you can understand that your eigenvalues are not distinct. Suppose if you have distinct eigenvalues, you will have two distinct eigenvectors. But there is only one independent eigenvector. It means that eigenvalues are repeated eigenvalues. From this, we can understand that eigenvalues of P are repeated. Eigenvalues of P are repeated. So the matrix has repeated eigenvalues. In the statements they have provided, P does not have an inverse. Sir, what is P? Please remember. Hello, please remember. Here P is not model matrix. Just to confuse you, they have given like that. Hello, it is not model matrix. It is original matrix. Original matrix. P is original matrix. Most of the students get confused and they will commit the mistake. So here P is not model matrix. P is original matrix. Catch my point? Wait. Don't conclude now. Please understand the concept. P does not have inverse is one statement. P has repeated eigenvalues is one statement. P cannot be diagonalized is another statement. Okay. P cannot be diagonalized is another statement. So which of the given statements are true? We have to identify. Catch my point? Now, concentrate. Please concentrate. Sir, if eigenvalues are repeated, if your eigenvalues are repeated, can you give the guarantee that matrix does not have inverse? You can't give the guarantee. Okay, because I have given one example. 2102. It has repeated eigenvalues. It has a repeated eigenvalues. Today only we have solved the problem, man. Here, observe this problem. Matrix is 2 cross 2. Repeated eigenvalues. Whether it is inversible or not. 2 into 2, 4. Product of eigenvalues is 4. Non-zero. Inversible or not. That's why it does not have inverse. You can't conclude. Okay. There is a possibility that it has an inverse. Okay. So you can't conclude that. Here also one and only one independent eigenvector. Remaining eigenvectors are multiples of 1, 0 in this problem. Okay. Is it diagonalizable? It is not diagonalizable because only one independent eigenvector is available. That's why it is not diagonalizable. Okay. Come to the problem. So, in this problem, P does not have inverse is false statement. P has repeated eigenvalues. Yes. P cannot be diagonalized. Yes. If you have any doubt, better to take this example. This is the example. Repeated eigenvalues. If you calculate eigenvector, you got only 1, 0. Only one linearly independent eigenvector. That's why it cannot be diagonalized. Okay. So 2 and 3, only 2 and 3 are necessarily true. Only 2 and 3 are necessarily true. Got it? Very conceptual question. Observe next problem. It is also designed based on similar concept, right? Let M be 4 cross 4 real matrix. Yes, real matrix. Okay. M has 4 linearly independent eigenvectors. M has 4 distinct eigenvalues. M is non-singular. Observe here. Which of the following statements are true? Which one of the following statement is true? Either S1 implies S2 or S1 implies S3 or S2 implies S1 or S3 implies S2. Please connect the statements. Please connect the statements. Observe. Sir, if the matrix has 4 independent eigenvectors, can you give the guarantee that 4 distinct eigenvalues? It is not necessarily true. For your matrix, if you have 3 independent eigenvectors, can you give the guarantee that all 3 eigenvalues are distinct? You can't give the guarantee, because if you have 3 repeated eigenvalues also, there is a possibility that 3 independent eigenvectors. That's why it is not necessarily true. Therefore, it is not S1 implies S2. It is S2 implies S1. If you have 4 distinct eigenvalues, 100% you have 4 distinct independent eigenvectors. So, if S2 implies S1 is correct statement. Okay, M is non-singular. Matrix is non-singular or singular, you can't say. In the case of singular also, there is a possibility that distinct eigenvalues and independent eigenvectors. I have given one example. Matrix M, lambda q minus lambda. There 0 is one eigenvalue, 1 is one eigenvalue, minus 1 is one eigenvalue. That is not inversible. M inverse does not exist. Still it is diagonalizable. I have given the example. Catch my point? It has linearly independent eigenvectors. It has distinct eigenvalues. But inverse does not exist. Okay? Next. Observe this problem. Let M is a 3 cross 3 matrix. Then the maximum number of linearly independent eigenvectors of M. First, your job is to calculate eigenvalues. Eigenvalues are known because it is triangular matrix. Our job is to find eigenvectors. Avadesh, calculate eigenvector. Don't use lottery system here. Lambda equal to 1. Consider A minus lambda I of x equal to 0. Now, M minus lambda I means 1 minus 1, 1, 1. 0, 1 minus 1. Lambda is 1, that's why directly I am substituting 1. 1. 0, 0, 1 minus 1 equal to 0. Okay. Since lambda equal to 1, 0, 1, 1, 0, 0, 1, 0, 0, 0. Is it in echelon form? Is it in echelon form? Yes, it is in echelon form. So rank of A minus 1i equal to 2. Total number of variables equal to 3. Therefore, geometric multiplicity equal to number of linearly independent eigenvectors equal to free variables equal to 3 minus 2. So in this problem, maximum number of linearly independent eigenvectors is 1 and only 1. Mr. Question mark. 1th element 1 is not necessary. It is only for convenience. Okay? It is not necessary. It is only for convenience. Even though you have 1th element is 0, no issue. Number of zeros before non-zero element are in increasing order or not. Cross check. Here 1 0, here 2 zeros. Okay, increasing. Therefore, it is in echelon form. 100%. That's why I have written rank is 2. Understood? Any innovative questions? Matrix is M cross N matrix such that all non-zero entries are covered in rows and columns. Then the maximum number of non-zero entries such that no two are on the same row or same column. In a row and B column. So number of rows are A. All non-zero entries are covered in A rows and B columns. Okay. Then the maximum number of non-zero entries such that A rows. So M minus A column. Pranshu, you posted these questions, these two questions in the WhatsApp group. I will solve it. Okay. Doubt solving group. In that you post it.